Today I'm going to be talking about point mutations. There are two different types of point mutations, and they can have four different effects on the amino acid sequence. As you may recall, DNA is made up of base pairs: adenine, which is a purine, thymine, which is a pyrimidine, guanine, which is a purine, and cytosine, which is a pyrimidine. Point mutations occur when one base pair in the DNA sequence is altered. There are two different types of point mutations: transitions and transversions. A transition is when a purine is changed into a purine or a pyrimidine is changed into a pyrimidine. A transversion is when there's an interchange between a purine and a pyrimidine. To demonstrate the four effects of these point mutations, here is an example of a coding strand of DNA. This coding strand needs to be transcribed and translated into amino acids to form a protein, and then we can understand how a mutation in the DNA affects the end result. First, let's transcribe and translate this DNA sequence. Since this is the coding strand, to transcribe it into the mRNA, we just have to replace all the thymines with uracils. Then, to translate, we must use our codon chart to match the appropriate amino acid to each codon. As you can see here, the AUG is a start codon and the UGA is a stop codon, and at the end you have these 5 amino acids: methionine, tryptophan, asparagine, alanine, and cysteine. So the first type of mutation we're going to talk about is the missense mutation. This is when there's a change in the sequence that results in a change in the codon, which can then code for a different amino acid than what was originally there. So as you can see here, here is the original DNA and original amino acid sequence that we showed before. And in the mutated sequence, you can see that a C is replacing the G, which is a transversion. And that mutated mRNA now has a UCG, and the mutated amino acid sequence now has a serine instead of a tryptophan. The next one is a nonsense mutation, and this is when a change in the sequence results in the addition of a stop codon earlier than in the original sequence. So again, here's the original DNA and original amino acid sequence. You can see that in the mutated sequence, there is an A replacing the C, and this causes a UGA, which is a stop codon, which then stops the translation earlier than it did in the original. Next, we have a silent mutation. This is when there's a change in the codon, but it doesn't code for a different amino acid than what was originally there. So it really doesn't have that much of an effect on the amino acid. For example, you can see here that a C is replacing the T, which is a transition, and the mutated amino acid is now a GCC instead of a GCT. But GCC and GCT both code for alanine, so there is not really a change in the amino acid sequence. And finally, the last mutation is the read-through mutation, which is when there's a stop codon removed from the original strand and is replaced with another amino acid. So as you can see here, in the mutated strand, you have a T rather than an A, which is a transversion, and your mutated mRNA has a UGU, and the mutated amino acid has a cysteine here instead of the stop codon, which would have originally been here, and the amino acid can continue